Hey scholars, welcome to chapter 19. This week we're looking at climate control and ozone depletion, how that's affecting our global temperature. And so that's what our topic is today. And our case study starts off with looking at a specific volcano, Mount Pinatubo, and understanding the climatic changes that come from volcanic eruptions. This happened in June 1991 in the Philippines, and Mount Pinatubo erupted and exploded. There was lots of airborne pollutants. There's lots of deaths of not only organisms in the island, but people as well, and damage and destruction of small villages. And the affected climate temperature, it actually dropped the temperature a little bit, actually caused the overall temperature, well, not over of the globe, but at least in the region, to drop tremendously because of that ash flying in the air. And climate predictions based on the forecasts of James Hansen and NASA. Hansen's model and 18 other climate models indicate that global temperature are likely to rise several degrees during this century, mostly because of human actions and to affect global and regional climates and economies and human ways of life. So even though this one scenario actually did drop it, the explosion would probably cool the average temperature of the Earth by actually 0.5 degrees Celsius or 1 degrees Fahrenheit over a 19th month period. So this eruption did bring the overall global temperature down a little bit, fraction, but not nearly enough to totally negate global warming and what humans are doing as far as their impact. So that's I'll do a little video for you. I'll drop a little video about the Mount Pinatubo eruption down below these videos in the extras, the bonus videos. This is what the eruption looked like in 1991. So let's ask the question: how might the Earth's temperature and climate change in the future? So what are we looking at as far as future goes? Because obviously we're okay right now as far as some of us goes. But where are we going in the future? And global warming and global cooling are not a new concept. Over the past 4.7 billion years, the climate has been altered by volcanic emissions, changes in solar input, movement of the continents from Pangaea to Gondwana, and just now the continents that you have today, even impacts by meteors. Over the past 900,000 years, we've had series of glacial and interglacial periods, cooling and warming, and vice versa. And so we've had that. It's not a new thing. Over the past 10,000 years, scientists have seen that we're in an interglacial period where we're kind of like, we have some glaciers, but not a whole lot as far as the whole world goes. Over the past 1,000 years, the temperatures have been relatively stable, not really changing. But over the past 100 years, we have seen temperature changes on the rise overall. And we're going to find out what was causing this. We found some of those reasons, and some of them had to end up being us. So those are our methods of determining this, and we've had lots of different methods. I'll explain a couple of them now. But this is just a graph that kind of talks about those time periods and looking at the cooling and warming, looking at average surface temperature. And this is thousands of years ago. So go back to 900,000 years ago. So you have seen cooling and warming as far as the surface temperature goes. When you look over the past 22,000 years, we've had the end of the last ice age. Agriculture was established. We're kind of in that interglacial period. Over the past 1,000 years, we're like that's representing this area right here, just kind of slowly going back and forth, really remaining stable as far as temperature goes. Temperature change has not been very much, maybe a degree, if that, not even. And then over the past 130 years, we've seen ups and downs, but slowly going up. So that's what we've seen. Now, one of the ways we determine this is using ice core samples. Obviously, no one was around hundreds of thousands of years ago. So what we've done is actually used a place on the planet that stays pretty consistent, and those are the Arctics. They've literally gone there and then drilled through the ice and basically took out core samples and sectioned them off. Obviously, the deeper the ice, the older the climate. And what they've done is they've analyzed the pockets of air or air mass inside of those ice chunks. What they've done is able to figure out what elements are composed inside of those air chunks, at what percentage were they, how was oxygen looking. They can tell a lot of different things from those core samples. And that's one way of kind of estimating and getting that data we just talked about. So our climate lives and economies depend on natural greenhouse effect. Greenhouse effect is a good thing. If without it, we'd be very cold and uninhabitable Earth. We'd have a series of very, very cold temperatures for the most part. So sometimes we'd have some series of warm depending on what time of year it was, but mostly the Earth would be very, very cold and uninhabitable. So I don't want you to get confused with global warming. Greenhouse effect is a good thing. Global warming is just like a super enhanced greenhouse effect, which is not a good thing. So we need greenhouse effect. Some human activities emit large quantities of greenhouse gases that trap in more heat. So since the Industrial Revolutions, carbon dioxide, methane, and nitrogen oxide emissions have been higher. Main sources come from agricultural, deforestation, and also lots of burning of fossil fuels, specifically in the last 100 years or so. The correlation of rising CO2 and methane with rising global temperatures, we've seen that, and I'm going to show you some images to show that in a little bit. And the countries we are one of the, obviously, the countries with the largest CO2 emissions. There are other countries with CO2 emissions, but anytime you're burning fossil fuels, that leads to CO2 emissions. Per capita emissions of CO2, actually, it says the United States actually has one of the highest. It says the United States emits about 5 times more CO2 per person than China, which is an up-and-coming country that's really producing a lot of CO2 because of their industry. We have 2 scientific studies we're looking at. One is in 2007, and it was done by Field and Marlin. And what they said was Field and Marlin came up with a few things, and one of them, it says if CO2 emissions continue to increase at the current exponential rate, about 3.3% a year, levels in the atmosphere will rise by 560 parts per million by 2050 and soar up to 1,390 parts per million by 2100, bringing about significant change in the Earth's climate and causing major ecological and economic disruption in the later half of the century. It also says that models indicate that we should try to prevent CO2 levels from exceeding 450 parts per million, an estimated threshold or irreversible tipping point that could set into motion large-scale climatic changes for hundreds and thousands of years to come. So they kind of estimated what is the parts per million we need to stay at as far as CO2 in our atmosphere, and if it goes over that, we could be reaching a place where we really can no longer, if we cut off all CO2 emissions, would no longer be able to thrive in the habitat that we know it on Earth as we know it right now. In 2008, Oppenheimer and Carson did a little study. They looked at who, there are a bunch of U.S. economists that basically found that China's growth in emissions of CO2 and other air pollutants was much greater than previously estimated. So they think that we underestimated CO2 emissions by China because of their industry. Now, again, we are still the leading per capita, but China is up and coming because of all the industry they have in that country. And again, ice core analysis of air pollutants has been done as well. Now let's take a look at this. These are that graph I wanted you to look at, and taking a look at CO2 and CH4 and looking at how that compares. Lost my mouse. Oh, there we go. So atmospheric levels. See how CO2 and CH4 compare to temperatures and rising sea levels. So this is again from core samples again. Taken thousands of years ago, 400,000 years before the present, and it shows that this is in CO2 emissions, very comparable to CH4 emissions. As you see, there are very similar peaks and lows. But if you look at temperature, that's where you see another correlation between these two that have very similar peaks, but they do as well with temperature and even sea level as well. So we can see the direct correlation as CO2 and CH4 rise in the atmosphere, so does temperature and so do sea levels. So that's kind of a scary thought. That's what we've been using to predict what might happen for the future. So the atmosphere is warming mostly because of human activities, and we figured this out because the IPCC, or the Intergovernmental Panel on Climate Change, came together and came up with some major assumptions, a bunch of scientists coming together and figuring this out. And they found out that 90 to 99% likely that lower atmosphere is warming. Between 1900 and 2005, the average temperature has increased about 0.74 degrees Celsius. And about the last 30 or 40 years, annual greenhouse emissions has been up by 70%. In the past 50 years, Arctic temperatures are rising almost twice as much as fast as the rest of the Earth. And the melting of glaciers and floating sea ice has increased as well. We've had increasing prolonged droughts, and over the last 100 years, the sea level rose by 20 centimeters, which isn't a ton, but we'll talk more about that coming up. So those are a few things IPCC came up with. And also Al Gore and IPCC were actually won the Nobel Peace Prize for all this research they did back in the day. We'll actually watch Al Gore's presentation that he got it for presenting the IPCC's information and research and conclusions. And that was called The Inconvenient Truth. We'll watch that a little bit, at least bits and pieces of it later this week. What natural and human influence factors could have an effect on temperature changes? Obviously burning more greenhouse gases increased meat industry because they do a lot of belching actually and produce a lot of methane that way. So there's lots of human influences that could go into increasing temperatures even further. One of and that's what the IPCC kind of talked about within their piece as well. This is just a couple of the images that you'll see later in the week when we look at the inconvenient truth. But this is just showing you different pictures. 1948 to 2004, looking at that was all ice. Now it's all melted water. This is also a picture of some kind of an image or a prediction from 1979 to 2007, looking at how much the North Arctic has melted. So what is the scientific consensus about future temperature change? A lot of you have you're very skeptics, and I applaud you for that. You should always do research and come up with your own conclusions. But we have used mathematical models to predict what might happen, and what we found was that we think that the global temperature will rise, and it will rise at a relatively rapid rate as we increase our use of fossil fuels. Human factors are the major cause, and they will continue to be the major cause. And humans will become the greatest risk to themselves as far as the climate goes and the planet. So that's kind of what we've seen so far in our consensus view of science. I'm not saying you have to believe this, but I'm saying science believes this as a whole. A majority of science believes in these theories. So simplified model of some of the major processes that interact to determine climate. We have obviously the sun coming through, aerosol emissions, greenhouse gas emissions. The aerosols take away, and they actually help cool. The greenhouse gases obviously increase the warming from decreased ice and snow cover. So the less ice and snow we have, the warmer the planet becomes. If we have more of that, there's cooling involved. If we remove CO2 by plants and organisms, that's a good thing. It cools the earth. If we burn stuff and the land is cleared and fires occur, then we are increasing CO2 emissions, which increases warming. The heat and CO2 removal from the shallow oceans and the oceans and long-term storage actually cools, but if we release that and those oceans aren't useful in holding on to that CO2 or the organisms in it, then the CO2 will increase, causing warmer of the Earth's temperature. Another image, this is just a comparison model, shows you kind of what, looking at projected changes. This is from 2007, is 1860 to 2007 is our data. And then we're predicting where might it go in the future. It could keep going it could continue to go on the high end and go out to be a temperature change of almost 4 degrees Celsius, which is huge and it's very bad. Or it could go a little bit low and still increase, but could only get to about 2 or maybe 1.5 degrees Celsius, which would be more beneficial for us. Let's ask some questions. So what is causing this? Is it just us, or is it something else? Some people believe it's the sun getting hotter. Maybe that's the culprit. Well, since 1975, the troposphere has warmed, which is the one closest to Earth, and the stratosphere has cooled, which is further or closer to the sun. So that's really not what a hotter sun would do. If it was that, it would increase the sun's rays. The stratosphere would become hotter because it's closer to the sun. So it's not really the sun that's strengthening. It's what we're doing within our own atmosphere, our troposphere, that's causing it to warm. So it's not the sun that's a hotter culprit. Can the oceans save us? The oceans hold a lot of CO2. They're great sinks. They have great solubility if they're cold enough. But the problem is when the ocean temperature warms, CO2 levels are going to increase acidity. It's also warmer waters can't hold as many gases. So that's going to not hold as many CO2, so more CO2 is in the atmosphere. And it's also going to kill coral reefs, which is another good sink for CO2, for at least carbon itself. So that is another. Those are warmer oceans. As global temperatures rise, the oceans aren't going to be able to save us. They're going to just end up keeping going in that positive feedback loop as well. Towards it's a positive feedback loop, but it's definitely a negative thing overall. We've seen the Antarctic, Southern Ocean, and the North Atlantic Ocean decrease in CO2 uptake and significance on global CO2 levels. Obviously, they're going to cause those to increase if they decrease in their uptake. There's an uncertainty about the effects of cloud cover. So people think that cloud cover might be helpful. Warmer temperatures create more clouds, and if they create thick clouds and thick light-colored low-altitude clouds, that decreases surface temperature. But we know that thin cirrus clouds at high altitudes increase surface temperature. So depending on warmer temperature might create more clouds, depending on which types of clouds they create, could have either a negative or a positive effect. Also, if you know about jet entrails, they're more cirrus in nature. So the more we fly through the air, the more jet entrails are created, the more, at least by this, more it would look like the surface of the Earth would increase as well, temperature would increase as well. So that's another thing to think about. So outdoor air pollution can temporarily slow global warming. Going back to this image right here, where it shows aerosols and natural and human emissions can, if they're aerosols, those are pollutants, can cause cooling. And so when we look at this, but it will not enhance or counteract the projected global warming. We just looking at Mount Pinatubo, that's a natural cooling one from soot and the air pollutant, but it only cooled it for so long, it wasn't a whole lot. And eventually that's going to fall, all those particles are going to fall back to the earth or washed out of the lower atmosphere by rain and whatnot. And so it's not going to be a permanent fix, which is going to be a bad thing. It might reduce it a little bit, but it's not overall going to do much, so especially in developed countries. All right, that brings us to the end of section 19.1. See you guys for 19.2.